So hi all, welcome to Malware Analysis and I'm J. Lavanya, Assistant Professor of CS Department. So today in this video, we are gonna see on the topic called extracting strings from a PE, classifying the malware using YARA. So let's go into the topics. So first one, so extracting strings from PE. So as we have already discussed what is meant by PE, you can just check out in the previous slides. Okay, I mean the videos. Okay, here like usually this extracting strings can give some clues about the program functionality and indicators which is associated with the suspected binary. Okay, for example, if your malware creates a file, the file name is stored as a string in the binary, right? So, or if a malware resolves a domain name, okay, and which is controlled by the attacker, then the domain name is stored as a string. So string is nothing but it's a collection of characters like ASCII values and some numeric symbols, all those stuff, right? And this strings is extracted from the binary where it contains some references to file names, a URL, domain names, IP addresses, attack commands, registry keys, and so on. And strings, they are ASCII and Unicode printable sequences of characters which is embedded within a file. And extracting strings can give clues about the various functionality, right? And this, although the strings do not give a clear picture, of the purpose and the capability of the file, they can give a hint about what malware is capable of doing. For example, extracting strings from P, that is portable executable file, is a common task in the malware analysis, reverse engineering, and software analysis. So you can just check out the reverse engineering, that is also I have posted in the video. You can just check it out. And why this extracting strings in PE is needed. And there are various ways also. Like, so first of all, the common method. The first one, string commands by using the Linux or the Windows. Second one, PE specific tools. And third one, like the Python approaches. So string commands like in Linux or Windows. Here, for example, string space slash n like for file.exe, if I'm mentioning in the sense, the minus n, that flag sets a minimum string length. The default is 4. Okay, and you have already seen what are the types of tools available for the specific PE, like PE View or CFF Explorer, PE Studio, and Beam Text. Okay, so all these stuff comes under the PE specific tools. And what are the Python approaches if you take? For example, if I want to extract the strings, you have to send the file path name followed by the minimum length, that is 4. The exact file path name you have to give followed by for which section you have, by using the for loop you have to use the get data method, and by means just store in a variable called data. And then for byte in data, if the 32 is less than or equal to the byte or less than the 1 to 27, so for printing the ASCII value, and the current string is equal to plus is equal to chr of byte, it will be printed. Or else if the length of the current string is greater than or equal to the minimum length in the string, it will be appending to the existing string. So that way we can able to return the string values. Okay, can you able to understand? So these are the common methods for extracting the string. And next one, what are the advanced techniques for extracting the string is that first one, extracting from a specific, from a specific section. So by using like dot text or dot or data or dot data, like text is nothing but code section. R data, that is read only data, this is common for the strings, and dot data, that is an initialized data, and Unicode strings like strings followed by space, a minus el space file.exe, okay, and followed by this, there's a little Indian code. Okay, that is a unique code where we'll be using some these kind of el cases. And for the resource string, the third one, for some resource hacker or similar tools to extract the strings from the users, you can go for these kind of techniques. Okay, so this is how we can able to extract strings in a PE. Okay, and apart from that also, we have so many string values where it is commonly used, and we can also automatically we can able to extract the values, right? So there are some stuff where like uh, by using some log command. Okay, so minus a log.exe also, it will be replicated and it will be automatically extracted. And similar to that also, we have like obfuscated strings from the malware using some Firefly Labs, okay, solver. And here, like by using some XOR operation, can just send the data by using the for loop, and the corresponding hash code will be based on the what type of XOR value you are providing. And it will be constructed on the stack where like in UP you have giving some commands, right? Like move from from this particular address R1 to R2, so this register to this register, we just pass in the address value, right? Similar to that, here also we can able to pass the slack strings. And the correct methods for combating this specified string by using some debugger, right? Because in Google Cloud, they'll be using these kind of dissemblers such as IDA Pro or Analyst, which can use a debugger to execute every code part that yields a decoded string. So they can do this by setting some breakpoints or manipulating the CPU flag at some important spots in the program. So when the malware decodes a string analysis, which dumps the region of memory that contains this data. So this technique uses a malware string decoding implementation, which must be decoded strings properly if the malware works correctly. Okay, so these are some of the flaws where you can able to extract the strings. Okay, can you able to understand? Yeah, and I'll just post some quizzes at the end of this session, so you just go for it. It should be displayed in the Google Classroom. Okay, so these are the advanced techniques. And next one, so why the string extraction, it is important in malware analysis, and why this string extraction from a PE file is a critical first step in a malware analysis, as it can reveal some command and control servers like C2 servers and then API calls or the encryption keys, okay, and then a persistence mechanism or victim identification markers. So that is why we are using the string extraction component in this malware analysis. So as we have discussed, right, the common string like basic string extraction from a malware PE file, first you have to use the strings utility, right? And followed by the ASCII or the Unicode strings, followed by the output to the result, like can be of IP, URL or mutex or etc. Nothing. Okay. So this is a step, and like if the using the text file like malware.exe files also. From there you have to go for the strings.exe followed by the extractor string, that's ASCII or Unicode, and then PE section or the specific extraction. And in the PE file section also we have just seen in the last video. You can just check out the previous video. There dot text, that is code, and dot R data, that is read only data, and more strings here, and dot data, that is initialized data, and dot rsrc is the resources. Okay, and by using some advanced string extraction like I just mentioned, right, by using the Python file also, you have to use XOR obfuscation strings, right? So many malware samples use some XOR encryption to hide some string values, or the XOR string to deobfuscation process also they will be using. from the encrypted string, they will be passing the values to the XOR decryption and followed by the clear text string. Okay. And at last, like a stack constructor string. So modern malware often builds strings at the runtime. So partial string or the characteristics which is forms is an assembly instruction. So that way we can able to complete the strings in the memory. Okay. And integrated analysis workflow, if you take like the first thing, we all know it's static malware analysis, extraction analysis, and dumping. And if it's case a dynamic analysis, we have to do some monitoring analysis in the text file. Okay, so this is all about the integrated analysis. Okay, so static, dynamic as well as cross-reference also in some rare cases we'll be going for it. Okay, and next, like common malware strings to look for is that like network indicators, persistence, or evasion, or payloads. Okay. In common malware strings to look for, in network indicators, we will be using some bot.php, that is 443, that is user agent. Okay. And in persistence, like current version, what your type of using in Windows or Microsoft, I mean in Windows. Based on that, we have to run the Slack task. And then evasion like VirtualBox, Sandbox, Wireshark, right? So based on that, you have to just fix the values. And you can just check out the codes which is present in the Google. You can just check it out there. Okay, so this is why the importance of string extraction in malware analysis. So here you can see this I've just taken a screenshot. So we are just passing the strings. Here I think you could be able to see that visualize. So strings minus n 6 dot text. Okay. So this is what I just told. So like n is that particular uh, string value and 6 is nothing but the default value where we'll be passing it. And once you have given automatically what are the things which is available, we can able to extract the strings from the particular exe file. And similar to that, so this is also the same thing. Here also I have given the same query. We can able to solve it. Okay. And next topic we are gonna discuss is that classifying malware using YARA. So this is a very important question in terms of semester. So YARA is nothing but yet another recursive acronym. Okay, so it's a powerful open source tool which is primarily, used in cybersecurity for malware research, detection, as well as classification. So it allows the users to create the rules based on some textual or the binary patterns which is found in malware samples. Enables them to identify as well as categorize the malware analysis, which helps the malware researchers to identify and classify the malware samples. And with YARA, you can create some description of malware families based on textual or binary patterns. And each description, which consists of a set of strings and a Boolean expression, which determines its logic. Okay. And so most probably here, this each description, like there is a rule which consists of a set of strings and allows the users to create the rules based on some textual or binary patterns which is found in malware samples, enabling them to identify and categorize the malware families. Okay, and the power of YARA lies in its flexibility and the ability to create rules that are specific enough to identify a particular malware family, yet generate enough to catch some variants of the same family. Okay, so mainly to classify the malware samples, we are going for these kind of open source tool. Okay, so how we are classifying this? This is structure a small example. Okay, it's not like there is some set of strings and a boolean expression where it determines some loss. So the rule is that So silent breaker is a backup. So metadata, this is just an example, like threat levels 3, in the while true, and strings we have defined. So A, B, C. The condition is that A or B or C. So based on this, the banker will be just checking. So this is the structure of a YARA, which I will specify as a simple example. Okay. And apart from that, also we have like YARA rules. I mean, how does it works like YARA? So YARA rules are essentially code snippets that describe the characteristics of a particular malware family. And first one, like if you take, it is defining the pattern. So defining the pattern means these rules specify the strings, a binary pattern, or other characteristics like file size or base64 encoding that are commonly found in a specific type of malware. Okay. And second one, like the Boolean logic. So these rules also include a Boolean expression that determines when a file or process matches the defined criteria, which triggers some positive identification. And third one, matching against files or processes. So when YARA is sent to scan files or processes, it compares them against the defined rules. And next one, a classification. If a file or a process matches a YARA rule, is classified as belonging to the malware family or type defined by that rule. So in that particular rule, in machine learning, you might have seen you'll be specifying some set of rules. Okay, so based on what the query will be passed, and if it is true or false, I have to check some condition, right? So similar to that, here also we'll be classifying the malware based on the samples of the rules which are provided inside the rule, like data type or all condition on all those stuff. Okay, so this is how the YARA rules will be defined. So defining patterns, Boolean logic, matching against the files and processes, as well as we'll be doing the classification. Okay, and what are the key features and benefits? So first of all, it is mostly flexibility, extensibility, community driven, and then versatile use cases. Okay, so what is meant by flexibility? So YARA rules can be customized to target some specific malware families, techniques, or even individual malware samples. Okay, and extensibility. So YARA supports modules that it extends its functionality, such as the PE module for analyzing the portable executables. Okay, and then community driven. So public YARA rules are shared online, allowing the researchers to leverage the knowledge as well as expertise of the broader security community. And versatile use cases is is used for some various tasks, like including the malware analysis, like identifying and understanding the behavior of different malware types, and threat hunting, proactively searching for malware in a network or a system. So instant response, quickly identifying and containing the malware infection. And threat intelligence, so gathering the information, about the malware families as well as their characteristics. So since YARA is open source, it will be very freely available and it can be integrated into some various security tools as well as the workflows. Okay, so these are the key features as well as the benefits. This is the main sorry, this is the main classification process and how it is classified. Okay, here you can see which we have some classification or some steps to be followed. Okay, and here the first one, gather the samples. So to gather the samples is that first we have to collect a representative set of malware samples for the family or type you want to classify, and then analyze the samples. So analyze the samples to identify the unique strings, code patterns, and other characteristics that can be used to create YARA rules. These tools like disassemblers, example IDA Pro, Ghidra, and debuggers like X64DBG are invaluable for this step. And writing the YARA rules. So write the YARA rules based on the identified characters. We start with some simple rules and gradually refine them to improve the accuracy as well as reduce the false positive. And test rule is that testing the rule against some large corpus of malware sample to ensure they're effective and do not generate too many false positives. Okay, and refine the rule, like if you're gonna use is that in refining the rule based on some of the test results, you have to adjust the strings, conditions, and other parameters to improve the accuracy and reduce the false positives. And deploy the rules. So deploy the rules to your security infrastructure mean, such as your endpoint detection and response, that is EDR system, or your threat intelligence platform. Okay, and monitor and update, like continuously have to monitor the performance of the rules and update them as a new malware variants emerge. Okay, so and apart from that, like YARA for classification, why it is used in the sense we have so many types, like uh, like it is mainly used for classification. Apart from that, and this yet another recursive acronym is also uses of cyber security purpose, right? What are the more effective to classify a malware, including viruses or worms or some ransomware. Okay, and why these kind of rules we are importing and why we are classifying. See, YARA rules identify the patterns that can be found in malware or families of malware, and in this way, they can indicate the presence of the malicious software. So, when a rule finds a characteristics or a pattern that indicate a piece of malware, then it can alert the appropriate person who can isolate or delete it. And what are the use cases for YARA? So YARA rules are actively used by the security teams to validate or clean the data before it is restored or shared. And whether it's integrated into some antivirus engines or layered into a backup environment, or YARA's flexibility makes it valuable for some security and data resilience. Okay, and YARA rules for malware detection. So YARA is built for one purposes, identifying the malicious code pattern quickly and accurately. Security teams use it to scan files, memory, and backup for some signs of known malware or malware families. So whether it's variants of malware or some specific strains of malware, and signature based YARA. So these YARA rules focus on some specific patterns that are common. It's known as malware, such as strings, hashes, byte sequences, code snippet, or file structure. The rules are precise and fast, which is ideal for catching some variants of threats that have already been studied and classified, right? And YARA rules for the file type, if you take, so YARA isn't limited to just malware. So it can also classify and filter the types by type or extension like .pdf or .exe. So this allows the security teams to identify the executable files or detect the embedded scripts, flag suspicious attachments in storage and backup environments. So YARA improves the visibility and the data engine. Okay, and then that is a ransomware detection with some these YARA rules. So according to Wayman, like in 2025, so ransom trends and proactive strategies report what they're saying is that 69% of the organizations suffered at least one ransomware attack in 2024. So top data resilience companies like VM offer built-in signature-based backup malware detection scanners to maintain the health and recoverability. So they also expanded some features, right, for analyzing, for anomaly detection, and for indicators of compromising the tool detection. However, for some specific rules that search for some specific malware or the patterns that can execute a ransomware attack, a YARA route is the best option, to find some malicious software and alert administrators. And one example of this YARA rule for these kind of classification is that can prevent some ransomware is CTB locker ransomware. Okay, which can found by looking like Kello, SPAD, like .pdb or Kemi132.dll file names. Okay, and these YARA rules scans for those files and alerts you immediately if they are found. So within the backup or at the time of recovery. And some rules and syntax is there, right? It's rule followed by to detect the malicious string. If the condition we have to specify the false command or all the stuff. And strings also in string section, we can able to specify the means of pattern, signature, or the strings we can able to define. So there are three distinct types of strings available in this particular what is that? This particular YARA. First one, hexadecimal strings, text strings, and then regular expression. So here hexadecimal strings are employed to define the raw byte sequences, whereas the structured text strings and regular expression are ideal for specifying some readable text segments. Additionally, text strings and regular expressions can also represent some raw bytes through the use of some escape sequence character like /n, /t, and all this stuff, right? And conditions. So this is the only required section since it refers to the Boolean or arithmetic expressions which is commonly used in all programming languages like and, or, not, plus, minus, star, slash, etc. Okay. And another type of condition could be the file size or match the length of the string. So there are many ways to create the rules with the conditions that meet these things. So metadata section also is needed where additional information about your rule can be included. Then a metadata section is defined with the keyword called meta, and metadata could include author's name, the data the rule was created, the version number of the rule, and the description of what the rule finds. Okay, and in the string section also there is a YARA rule which can look for several types of strings including those that uses some hexadecimal in combination with some jumps or alternatives and wildcard value. Okay, so here we can able to define. And what are the rules, for making the YARA rules? Build the templates to stay consistent and more organized. And using some standard YARA rule, we can able to do convention and contribution to the real repository to help the broader cybersecurity community if you just want to make a note of it. And there are some YARA GitHub repository or YARA documentation and YARA rules and signature repository where you can able to enhance your particular value. And you'll be having that. How do they work? Like whether scanning and backup is needed, right? Yes, scanning backup can provide some restore point where the files are first around provide some information such as timelines, to assist some instant responses. For all those stuff, you can go for these kind of YARA scanning. Okay, and most probably if you take like these YARA approach, they'll be used in cyber security concept also. If you're going through some YARA concept in the sense, they will be using these kind of classification to analyze the value. Okay, and these there are so many journals where they have publicized this concept and have got reputation, right? Here also you can define some rules. Okay, so there where they can contribute some for some private company that we can able to design for some Windows as well as Linux OS. Okay, and here also this YARA we have to first detect, as I have told already. We have to deploy the rule, like implement the rule in the security infrastructure, refining the rule, like adjust the rules to improve the accuracy and reduce the false positive. Third one, we have to test the rules, evaluate the rule effectiveness against a malware corpus, and write the YARA rules, create the rules based on the identified characteristics, and analyze the samples. So identify the unique characteristics as well as the pattern. So these are the steps for doing the effective malware classification in YARA. Okay. And in next one, we are gonna discuss is that what are the advantages? What are the advantages of using these malware classification process? So we have seen what are the malware things or why we are doing these kind of things. The first step, this advantages is that modules, right? So YARA modules allows you to access some information about the file being scanned, such as PE header, imports, as well as the exports. And this is extremely useful for targeting some specific file types and characteristics. And global rules, second advantage is that in global rules also, they are automatically applied to all files being scanned, and they are useful for defining common characteristics or for some pre-filtering files. And third one, like includes, you can include some other YARA rules in your rule file using the include directive. So this allows you to organize your rules into some modular components. And the third advantage is that you can go for some various variables. You can define the variables within a rule to store the values and reuse them in the condition. Okay. So this is all about the malware, and we have already discussed. So in this particular video, we have discussed on the topics like why we need the or why we need this particular P for classification purpose, right? So for extracting the strings. So since there are common methods like string command, Linux or the Windows or the P specific tools or the Python approaches we can able to use, and advanced techniques like extracting from specific sections and Unicode strings and resource strings. Okay. And next, we can go for why string extraction is important in some malware analysis. So that also we have already discussed, right? Like basic command and control servers, API calls, encryption keys, some persistence mechanism or victim identification markers. Yes. And we have seen what are the steps to be followed, like obfuscations or stack construction strings, and some extracting like static or dynamic, right? And we have also discussed the programs in Python approach as well as some rules. And next topic we have discussed is about classifying the malware using the YARA tool. So YARA is mainly used for classifying and identifying the malware by creating some set of rules. Okay, and these rules will be working based on some specific pattern, logic, or the uh, cases. And there are some uh, specific rules for it, that will just follow it. And what are the advantages of using these YARA features, and what are the benefits of it, and what are the features using this, and how this YARA is used for some malware classification, and what are the steps to be followed for malware classification with YARA. We have to like gather, analyzing the sample, write the YARA rules, test the rules, and then refine the rules, and then deploy the rules. Yes, and we have to monitor and then update. So there are totally, 5 steps in discussed with this particular session. Okay, I hope you all be well aware of this particular extracting strings from a PE, as well as we have discussed of the uh, YARA tool, how to use for classification the malware. I hope this video is very useful for you all. Thank you all. We will see you in the next video. Thank you.